Hello, welcome to Discrete Structures. This will be the continuation of our topic after the logical connectives. So today we will talk about the logical precedence or precedence of the logical operators. So welcome, let's go ahead and start with our topic. So we will talk about the precedence of logical operators. It only means that we have to know whom do we get the truth value first. We have to follow the precedence level. So it's more like MDAS. It's pretty similar to MDAS in mathematics. So if we have multiple operators at the same time, say for example, we have multiplication, division, addition, and subtraction in one problem. Therefore, we follow the MDAS rule. So we first solve the multiplication, and then we follow the division, and after that the addition, and lastly the subtraction. So the same with the logical operators. So we have here the precedence level, the first up until the fifth. So the first one that needs to be solved first is the negation. We have to get the truth value of negation first. And then the second, the logical conjunction or the AND operator. We have the logical disjunction or the OR operator. And the implication, the if-then operator. And lastly, the biconditional or the if and only if operator. Okay, let's proceed. I have given here the propositions value. We have the proposition P, Q, R, S, U, V, and they have its own value. Okay, so let's first try to solve. Okay, get the precedence of the first statement here. We have the not P and Q. Okay, so we have two operators, the negation and the AND operator. So based on the precedence level, we first get the negation before the AND operator, which is the logical conjunction. Therefore, we first get the truth value of not P before we get the value of AND Q. So how do we get that? Let's try it here. So I'll use the exclamation mark for the negation, not P. Therefore, we parenthesize it. We put parentheses on this one to emphasize that we will have to get the value of not P or negation P first before we follow the AND Q. Okay. Now, we have the not P. The value of P here is true. If we negate the value, it will become false. Therefore, not P is false. And we copy the value of AND Q. Therefore, we put AND operator and the value of Q, which is true. Therefore, false and true. Now, we get here, we try to solve false and true based on the logical conjunction. The only time that the truth value will be true if both proposition is true. Therefore, this statement here is false. Okay. Therefore, this concludes that not P and Q is false. Okay. The truth value of not P and Q is false. You see how we use the precedence of logical operators here. We first get the value of the negation because it is the rule that we have to get the truth value of negation first before the AND operator. Let's try to have this next operator. We have the not P. Okay, we first get the value of not P and we get the value of the not P. Okay, so let's try to put it here, not and then not P. Okay, so we get the value of not P. So the negation of truth here, the value of P is false. Okay, then we add the not operator, which is yung nasa outside. na operator. Since we are already done with this operator inside, we have first got the truth value for this operator. Now we get the operator for the outside operator, which is the not. Therefore, not false is true. Okay. Now, therefore, the not p, the truth value of not p is true. Okay. As you can see, we follow the precedence of logical operators. We get the negation of p first. Okay. Let's try another one. Let's try this P or Q and R. Okay, as you can see, we have two operators. We have the OR and the NOT. The AND operator. Based on the precedence level, we first get the AND operator before the OR operator. Therefore, we first parenthesize the AND operator, which is Q and R. Okay, we parenthesize this to emphasize that we have to get the truth value of P and R first before the P or Q and R. Okay, this is how it will look like. P or open parenthesis Q and R. Okay. Now we get the truth value of Q and R. Okay, so the value of Q is true. The value of R is R. True or true is equal to true. Okay, so therefore the value of Q and R is true. So we put true. And then we copy the OR operator and put the value of P, which is true. Okay, again, the value of P here is true, therefore we put true, and we copy the OR operator here, and we get the value of Q and R, which is true. Now we solve this. True or true is true. Therefore, we conclude that the truth value of this statement is true. Okay. Now you see how we use the precedence level in this statement. We first get the truth value, or solve first the AND operator or the logical conjunction before we get the truth value of the logical disjunction. Okay, I hope that's clear. Let's try to have this one. We have three the same operators. We have P or Q, Q or R, and R or S. R and S. Okay, it is the AND operator. We have three operators, the AND operator here and another AND. Okay, so now based on the rule, we first get the truth value of the first operator on the left. Okay, since we have the same operators, we get the value first on the left operator. So the left side here is this one, the P and Q. Therefore, we parenthesize P and Q, and then the R, and then the S. Okay, it will look like this. P and Q, close parenthesis, and next is the AND R, close parenthesis, and the last one is S. Okay, this is to indicate that we first get the value of P and Q. Okay, according to the rule, we first get the truth value of the operator on the left if they have the same operators. Now we get the value of P and Q. Okay, the value of P is true and the value of Q is true. True and true is true. Okay, let's put an open parenthesis here, and we copy the AND R. We copy the AND operator, and the value of R the value of R is true. Okay, next we copy the next operator, which is the AND operator again, and the value of S, which is false. Now we solve the value of true and true. Okay, true and true is true, and we copy the and false. Okay, so and false. Okay, true and false is false, therefore this statement here is false. Okay, I hope that one is clear. To make it short, if there is the same operators, we first get the value on the left operator, and so on and so on. Okay, let's have this one here. We have the same operators again. We have two AND operators, and we have two OR operators. So based on the precedence of logical operators, we first get the truth value of logical conjunction. Okay, that means we first get the P and Q and U and V at the same time. Now it will look like this. Open parenthesis, P and Q. Okay, and we copy this one here, the OR R, and then another OR operator, because we have to put parenthesis for this AND operator here. Okay, so let's copy OR R and the OR operator again, and open and close parenthesis, the U and V. Okay, again, based on the logical precedence of logical operators, we first get the truth value of the AND operator. We have this AND here and another AND operator here. Therefore, we put them in open and close parenthesis. Now, we have the next situation wherein it has the same operators, which is the OR operator. So based on the rule, we first solve the operator on the left. Therefore, we have to parenthesize the and the OR R. Okay, and we have to solve this one last. Okay, now we first get the value of P and Q. The value of P and Q is true and true, therefore it is true. Okay, now we copy the value of OR R. Okay, we copy the operator OR and the value of R, which is true. And we copy the OR operator again, and we get the value of U and V. Okay, so U, the value of U is false, and the value of V is false. So false and false is false. Okay, now we get the value of the P and Q, which is here, which is true. And we get the value of OR R, which is this OR, and true, the value of R is true. And now we get the value of the U and V, which is false. So we copy now the OR operator. Okay, now we get this value. We get the value of true or true. True or true is true. And we copy the or false. Okay, so true or false. True or false is false. True or false is true. Okay, because when we use the logical disjunction or the OR operator, the truth value will always be true if at least there is one true in the proposition. Okay, therefore we conclude that this statement here, or the value of the statement here, is true. I hope you can see how we follow the logical operators for this statement. Okay, we first get the truth value of the AND operator here and the AND operator here, and then the left OR operator before the last operator. Okay, next, let's proceed with the second to the last statement. We have the three kinds of operators. We have the AND operator, the then or the implication, and we have the logical disjunction or the OR operator. So we follow again the precedence level. We first get the truth value of the AND operator, which is P and Q. And between the implication and the logical disjunction, we get first the value of the logical disjunction or the OR operator. Therefore, we should parenthesize the P and Q and parenthesize the P or Q. Okay, so it will look like this: open close parenthesis P and Q, and we copy the then implication and the open and close parenthesis P or Q. Okay, now that we follow the precedence level, which is we first get the and the OR, we get the truth value for the P and Q first. So truth value of P and Q is true, and then we copy the then or the implication, and we provide the truth value. We get the truth value of P or Q. True or true is true. Okay, if true, then true, therefore it is true. So this is implication. No, if the hypothesis is true and the conclusion is true, therefore the answer is, the truth value is true. Okay, so let's try to use the other solution for the implication. Instead of using the implication or the then operator, we implicate, we will use the negation of true or true. Okay, so not true or true, therefore it is true. So as you can see, the same answer with the implication. Okay, next, let's try the last one. So we have three implications. Okay, therefore, based on the rule, we first get the operator on the left before the next and the next. Okay, so left side first, left operator first. Therefore, we parenthesize this one, the P then Q, and then after that the then R and then S. Okay, so it will look like this: parenthesize the P, then Q, then R, then S. Okay, this is how it will look like. Now we parenthesize the first operator that needs to be solved first before the other operators. Now we get the value of P then Q. True then true is true. Okay, is true. Then we copy the value of then R. So then R is true, then true. Okay, and we copy the implication, and the value of S is false. Okay, now that we have here an answer, we get the value of, if true then true, it's still true. Okay, true. Then we copy the implication operator and copy this one here. Okay, then false. Now we get the truth value: if true then false, therefore it is false, based on the implication table here. If the hypothesis is true and the conclusion is false, therefore it is false. Okay? Therefore, we conclude that this statement here is false. Okay, I hope you all get the precedence of logical operators. If you have a question, don't hesitate to ask me and message me on our MS Teams group chat, or you can personally send a message in Teams or in Messenger, depends on what what platform that you are comfortable of using. Okay? Please stay tuned and watch the next video for the tautology and contradiction. We will solve, okay, we will prove that tautology, or this statement here, is tautology and this statement here is false. Okay, see you on the next video. Have a great day ahead. Bye!